Okay, welcome back and to the next lecture of energy conservation and waste heat recovery. So today we will take up a completely new topic, and that is called hydrogen economy and fuel cells. Okay, so hydrogen economy and fuel cells, it's an important topic. This is a topic that has gained more and more attention over the last 2 decades, I would say. Towards the late 90s is when they started really picking up. So given compared to, let's say, coal or natural gas, etc., hydrogen that way is very new. Okay, it's very new topic, and there are still lots of lots of different opinions about how good is hydrogen as an energy source and so on. Okay, so let's talk about that. Let's understand what hydrogen economy means, what it is, and also we are going to talk about fuel cells, which is again an energy generating device that uses hydrogen as a fuel. Okay. So what is hydrogen? Okay. So we are going to talk about hydrogen overview, then hydrogen economy, and then about fuel cells a little bit, right. So as I said, hydrogen economy means we are looking at hydrogen gas or hydrogen as an element as a fuel. So why is it fuel? Why is it good as a fuel? Okay. So if you look at hydrogen, the energy content per unit mass is very high, 142 megajoules per kg. If you consider gasoline or petrol, which we put in our cars, that is about a third of this. So per kg, per unit mass, hydrogen probably is one of the highest energy sources. So that is the attractive part. Okay. And second attractive part is hydrogen is abundantly available in nature. Okay, which is also a drawback, by the way, we will come to that. However, we should keep in mind that hydrogen is probably the lightest element, all right. So since it is very light, if we talk about energy per unit volume, then that is very low, okay, because it's the density is the lowest among all elements that we know. So therefore, even though per unit mass the energy content is very high, to store that unit mass or to have a storage for that unit for a given mass of hydrogen, the volume required is humongous. Okay. Now next thing I said that hydrogen is readily available, is abundantly available in nature, but unfortunately it is not abundantly available in its atomic form. It makes up of about 75% of the matter in universe, but in the free form as just hydrogen, whether hydrogen gas or liquid, it is not available. It is mostly available as an element in water, H2O. So therefore, if we want to use hydrogen, we have to first break down water into its constituent elements and separate out hydrogen and oxygen and then use the hydrogen. Okay. Or in wherever it is available, we have to first break up that compound and extract the hydrogen out as an element in the gaseous form or in the liquid form, whichever form is available. Okay. So this is about hydrogen. If I talk about what is hydrogen, why is hydrogen even being looked as fuel, is because it has very high energy content per unit mass, but the problem is it is not readily available. Okay. If you think of coal, fossil fuel, natural gas, there are reservoirs that are in which it is available today to us. Yeah, you have to mine it, we have to explore the natural gas out, we have to mine the coal. Even if we talk about biomass, yeah, that is there. Or if you look at the renewable sources, wind, solar, these are all energy sources are available to us in nature. Okay, but hydrogen is not available. So you have to spend energy first to get hydrogen and then use it as an energy source. Clear? All right. So with that introduction, let us look at the history of hydrogen economy. So I will start with a first vision, which is a little philosophical. Jules Verne, Jules Verne in his science fiction adventure called Mysterious Island, he says that water will be the coal of the future. He writes that. Okay. So if you talk about the first vision of looking at hydrogen, probably that is embedded in this statement, and what Jules Verne thought about when he wrote about this, we do not know. Okay. But then the discovery, this was just a vision, that imagination that he had, it's science fiction, right. But discovery, Sir William Grove first demonstrated fuel cell operating principle way back in 1839, and also independently around the same time Sean Bain, he also demonstrated it independently. So remember 1839, okay, very many years back. So Haldane predicted the production and storage. The Haldane predicted that hydrogen derived from wind power via electrolysis, liquefied and stored, will be the fuel of the future. All right. So you have to get hydrogen from wind power via electrolysis. So you use wind power, the electricity that is generated in wind turbines, that is used for electrolysis of water, and then you liquefy the hydrogen, pressurizing it, and then store it, and that you can use it as a fuel. Okay. What is the cost of generating that fuel? Of course, that probably is going to be high. We will come to that. Application and transport. Lawaz-Check, he outlined the concept of hydrogen powered vehicles in 1920s. So you can see this, the isolated inventions and discoveries and findings date back a long way back to the 1800s, 1920s and so on. So this is the first person to suggest that hydrogen could be transported via pipelines like natural gas, similar to natural gas. Okay. So he said, like, just like we go to gasoline, his vision was just like we go to a gas station or a petrol pump where the petrol or diesel is either transported by pipelines or transported through trucks. He said that even hydrogen in future could be could be transported via pipelines similar to natural gas. Okay. And then the sustainable system, here are a few statements about that. So I am not going to you can just read it, right. So this kind of is a snapshot of hydrogen economy. Okay. So hydrogen production, how do we look at hydrogen production? How do we produce hydrogen? As we say that hydrogen is not available, we have to produce it first. So present methods of hydrogen production are few. Steam reforming of natural gas. So reformation reaction, we looked at chemical energy storage, where from methane we were able to get hydrogen as a product. So methanation and reformation, so it is the same thing, steam reformation of natural gas. All right. Biomass gasification, so all these have hydrogen as an element, right. Steam reformation of bio oil, clear. Then partial oxidation of hydrocarbons to get the hydrogen out, hydrogen, carbon monoxide, carbon dioxide, water vapor may be the products. Okay. Coal gasification, these are the ones that are used today, but if you look at the cost of producing hydrogen as a source of energy using any of these methods, it is pretty high. Okay. We see for 1 gigajoule, which is not a very high number, for 1 gigajoule the cost is $6 to $15 using any of these. Okay. And these values may change a little bit, these values change as any of these processes are also changing with time, these values can change, the cost can change, but what I am trying to say, suffice to say that this is pretty high. Okay. 1 gigajoule is actually less than 1 megawatt hour, right. So just this is the cost of producing that source of energy, and then you are going to use this hydrogen as a fuel to generate energy, which again will have its own cost, right. And again remember that the cost of mining coal, cost of exploring or digging into the reservoirs and getting natural gas out, they are not very high, they are much lower compared to this. And if you think of electrolysis of water, which is actually using electrical energy to produce hydrogen, which again we are saying that we are going to use hydrogen to eventually produce electrical energy. So this kind of a a roundabout situation where electricity is being used to produce electricity, and of course there will be losses in the in the processes. So the cost there is almost $20 per gigajoule. So definitely they are very costly today, and compared to the other sources of energy that we have today. all right. Okay. So, the challenges for hydrogen as fuel, of course, generation is definitely one. The second one is storage, because it is a large volume for a given mass. Okay. So, these are some of the methods that are being thought of. Compressed gas storage in underground tanks. Remember, when we talked about compressed air energy storage, we said that compressed air storage is competing with storage of hydrogen, liquefied hydrogen, or compressed hydrogen as gas. Okay. So, we are told that it is competing with hydrogen, compressed hydrogen also, as well as LNG, which is liquefied natural gas. Compressed storage and transportation in pipelines, and that typically is in the gaseous compressed gas or liquid form. Liquid hydrogen. So, this is an energy intensive process and transport is hazardous, because hydrogen, again keep in mind, as we will talk later, is a highly combustible fuel. Next one is metal hydrides. So, this actually is good. What is happening is, these are some metals which sort of absorb this gas at room temperature and release it on slow heating. When you elevate the temperature a little bit, the hydrogen will be released. But the issue is, those elements are platinum, palladium, which are extremely expensive. Okay. Right now, some rare earth metals and some other rare earth elements are being also looked upon for for absorbing hydrogen at room temperature and releasing on heating. So, that is also that is one topic under research. And finally, glass microspheres. This is also very attractive and very nice technology that is again under evaluation. So, glass microspheres, okay, these are doped glass microspheres which are used to store and release hydrogen. Okay. So, these are some options of storage that we have today that are being looked into, and that have probably been proven, if may not be at a very large scale, but have been proven to be good candidates for storage of hydrogen as fuel. Okay. But this is a challenge, and the other challenge is combustion, because hydrogen is highly combustible fuel. Okay. And the other issue is, the flame, when it burns, the flame is invisible and it spreads rapidly, because it is very light, right. The density is so low that it will spread. So, that is a problem. Okay. So, we need to keep it in mind. I mean, just because something is hazardous if it is combusted should not stop us from looking at it as a good source of energy. Okay. But we have to be careful with any fuel. So, that is what I come to in the next lecture, in the next slide, the safety of hydrogen fuel. The hydrogen could be unsafe if handled improperly, because it is highly inflammable with invisible flames, which is what we are talking about, but that is true for any gas, even when we, or even for any other energy source. When petrol and diesel, we see those trucks, we see that highly inflammable, right. So, we have to take good care and we have to be careful. The problem is, there are historically two incidents that have severely tainted the reputation of hydrogen as a safe fuel. The first one is called, it is a very tragic accident called Hindenburg Incident in 1937. Okay. So, Hindenburg, in those days, I mean, right now we see these jet planes. In those days, there were also these things called airships. So, airships, there was one called Zeppelin. So, airships typically used to have these compressed hydrogen tanks inside, and then there was a large metal frame, and then there was a fabric around it. So, that used to be the aircraft plane, and of course, it did not fly at very high speeds like the jet planes of today, but you could use it. I mean, that was pretty regularly used for flights. Okay. The Hindenburg incident, where the airship, the Zeppelin, caught fire and that led to loss of 36 lives, it is very landmark incident because it forever changed the face of the aviation industry. After this incident, airships were never used again, and we went on to the jet planes that we use for flying today. Okay. However, that being said, there are several theories that go around the Hindenburg incident as to why the explosion took place, why the plane caught fire, and there is no conclusive proof that the accident happened because of hydrogen, because of combustion of hydrogen. Okay, and that was a trigger. There are lots of theories. This was a, this was the plane belonged to Germany. So, there are several conspiracy theories, sabotage theories, etc., etc. So, I do not want to get into that, but I will show you a video, because this is a very historic incident. So, we should know about it. The other thing is the hydrogen bomb. Okay. Now, let me be very clear, apart from just sharing part of the name, hydrogen bomb and hydrogen as an energy source has nothing in common. Okay. Hydrogen bomb has nothing to do with hydrogen as energy source. Okay. It is just like saying that, and we know that atomic bomb, nuclear bomb, of course they are there, but does it mean that anything else, anything related to nuclear energy is bad? No, right. Okay. It is like any other fuel also. I mean, coal can be used, or natural gas can be used to generate electricity. Petrol and diesel can be used to move our cars or trains, or for transport, or to moving vehicles. Okay. But both of these can be used for arson. So, if you misuse anything, of course that is there. So, hydrogen bomb and hydrogen as energy source has nothing in common. All right. Okay. What I will do is I will just deviate a little bit now and show you a small video, which is the very tragic incident of Hindenburg. It is a short video. This is a Zeppelin aircraft.
Nearing the fatal end of her first Atlantic trip of the season, the Hindenburg approaches the mooring mast at Lakehurst. 21 of these sky voyages the world's biggest dirigible has made, so safely, so surely that the experimental service has become a matter of routine. Scarcely 100 feet above ground, the giant airship, with her framework encasing 7 million cubic feet of inflammable gas, is being carefully maneuvered towards her hangar, when suddenly appalling tragedy is a matter of seconds. It seems almost incredible that anyone should escape, yet 2/3 of those on board survive what is, next to the R-101 disaster, the worst in the history of aviation.
Okay. So, very tragic incident. As you see, it happened just moments before it was landing in New Jersey. Okay. So, within minutes 36 lives were lost of passengers and crew together. But that being said, also there is a positive part of it is, I think more than 2/3 of the lives were saved. Okay, of course 36 loss of lives is tragic, but many people were also saved. And one of the reasons was hydrogen fuel being light actually moved up. Okay. So, anyway, so Hindenburg incident, that was a little detour, but I wanted to show you as to what happened actually, and when the Zeppelin caught fire. And it is a landmark incident even in another respect, is because, as I said, it forever changed the face of aviation industry, because these airships, hydrogen powered airships, were never used again. All right, and we went to gas turbine powered jet engines. All right. So, what we will do next is, after this brief discussion on hydrogen economy and hydrogen as fuel, we will move into fuel cell. And fuel cell actually uses hydrogen as the fuel, okay, to generate electricity. Keep in mind, this is also an electrochemical device like battery, okay, where chemical energy is converted to electrical energy directly. All right, but battery can be used to store energy, whereas fuel cell is direct conversion real time. There is no storage involved. As long as you supply fuel, you are going to get energy generation. Unlike battery, where it will supply energy during the discharging cycle, but then at beyond a point it will discharge, and then we will have to either throw it away if it is a single use, like in our torches or in our clocks or in our remote controls, or we will recharge it like we do for our cell phones, for our laptops, etc. Okay. So, what we will do is we will now move on to fuel cell. So, what is a fuel cell? So, fuel cell actually uses hydrogen, as I said, as an energy source. So, fuel cell consists of electrodes and a catalyst. Okay. So, any fuel cell will have like a battery, has two electrodes and an electrolyte. Okay. So, as we will see later, there is one form of fuel cell which is called a proton exchange membrane fuel cell, and what it does is it allows protons to flow through, and while sort of stopping the movement of electrons. Okay. So, what happens is there is these electrodes is a catalyst where the hydrogen, when it reaches there, it dissociates into electron and proton. Okay. So, if you take a monoatomic hydrogen, if you remove the electrons, then what we are just left with one proton. That proton moves through the through this proton exchange membrane to the other side of the electrode, where what comes in is air which has oxygen. Okay. So, these protons actually then in the presence of the catalyst react with the oxygen molecules. Now, what happens to the electrons? So, when the electrons are separated at this electrode, we attach an external circuit. Okay. So, this electron actually flows through that external circuit and comes to the other electrode, where it recombines with the proton to produce hydrogen, which then combines with the oxygen to produce water, and what comes out therefore is the air minus some oxygen and water vapor. Okay. And it is an exothermic reaction, so therefore, you are also going to generate heat. Clear? So, what is the input in a fuel cell? Input in a fuel cell is hydrogen mainly, because that is the fuel, and oxygen, which is available, I think, quite insignificant amounts in air. And what comes out of the fuel cell, apart from electricity that is generated, the byproducts is heat, definitely, because it is an exothermic reaction, and then it is water vapor. Okay. And of course, unused air. Clear? So, this is conversion of chemical energy from a fuel directly into electricity. As we will see, it has high efficiency. Okay. Why it has very high efficiency? It is an extremely high efficiency, we will talk about that. It has low noise. Actually, there are no moving parts that way, apart from having some kind of a pump or some kind of a driving force to have the hydrogen and air flow through. You don't have compressors and turbines or pumps. I mean, maybe a small amount of pump, that is about it. Okay. So, it is low noise that way. It is a stable power generation as long as the fuel supply is stable. Okay. And it is less polluting. So, what is an ideal application for such a fuel cell? An ideal application for such a fuel cell is actually cars, one of the ideal applications. Okay. It depends on it depends on the temperature, etc., but in cars you can think of, especially when we talk about electric cars, right, we can use fuel cell as a source of electrical energy, or even hybrid vehicles, the electrical part we can use as fuel cells. But of course, there are challenges. So, most of the electric vehicles and hybrid vehicles that are available today in the market commercially is being driven by batteries. Okay. But fuel cell is an equally strong contender, if we can bring the cost down, if we can bring the size down, make it compact and so on. Okay. So, this is how, in a nutshell, what is a fuel cell and an application of generation of electricity using hydrogen as a fuel. Okay. So, with that small introduction, what we will do is we will stop today or stop this lecture, and we will continue in the next lecture with further description of fuel cell. Okay. So, let us kind of recap what we discussed in this lecture. We started by saying that hydrogen is an attractive source of candidate to be used as fuel. Why? Because its energy content per unit mass, remember calorific value or heating value, that is very high, 3 times that of gasoline that we use in cars. So, very attractive, but of course, it is a very light element. So, the volume required for a given mass is much larger compared to any of the other fuels that we use regularly. Okay. But one of the big drawbacks is hydrogen is not available freely in nature. It is available. It is available, probably 75% of matter in the universe contains hydrogen. Okay. The biggest source is water. Okay. The water is H2O, so hydrogen is available. Natural gas has hydrogen, any of the hydrocarbons have hydrogen, coal has hydrogen. But the thing is, we have to extract the hydrogen from all these matters or from all these sources, and for that we need to use electricity. And the cost of electricity, of course, or the energy cost involved to just generate hydrogen is quite high. So, that is a problem. Okay. So, we really have to see that we are incurring additional cost to generate the hydrogen. So, are we going to get the returns, because for a given mass I get a lot more energy. All right. The other thing that we said is storage of hydrogen is a challenge, because it is a light element, so it requires large volumes. So, we have to think of compressing it and storing it, or liquefying it and storing it. And the 2 other things that we talked about is storage in the form of metal hydride, storage in the form of glass microspheres. All right. The other thing we said was hydrogen is a highly combustible gas and the flames are invisible and it spreads very rapidly because it is light. So, that way there is a little bit of safety hazard using hydrogen, but then honestly every fuel has some safety hazard. So, as long as we are careful, we should not be too worried about it. We should be conscious, we should be aware of the dangers involved and take adequate precautions so that it does not lead to any safety hazards or any accidents. Okay. So, with that we also said that we also took a little diversion and talked about the Hindenburg incident, where these airships which were hydrogen powered, the Zeppelin, which was the last airship, crashed in 1937. It was a very tragic fire accident, but whether that accident happened because of combustion of hydrogen, the jury is still out. There are several theories that do the rounds, including sabotage, including using an inflammable material on the outer surface and so on. So, we do not know. So, it is not conclusively proven that the accident happened due to use of hydrogen as fuel. All right. Okay. So, with that brief discussion on hydrogen as fuel, we moved on to and we introduced the concept of fuel cells, where hydrogen, which is a device that converts the energy trapped in hydrogen directly into electricity. Okay. So, what we will do is we will pick up from here, and in the next class we will continue with our discussion on fuel cells. Thank you very much.